Hello, students. This is Ms. Medina, and we are going to work on Unit 2, reviewing Unit 2, okay? So one of the things about Unit 2 is that it brings back your integer properties, and it wants to make sure that you understand how they apply to when we're solving for equations. So if you have that A equals B, right, you already know that A equals B, like 10 equals 10. So what happens if you add the same number to that 10? Well, you're going to get the same number, right? So this one is known as the additive or the addition property of equality. It goes something like this. If you know 10 equals 10, right? So if you do 10 plus 2, is that also going to be equal to 10 plus 2? Yes, because 12 equals 12. All right, same deal on the next one. Okay. It says that if you know that A equals B, then if you subtract the same number from both sides, right, do you still get the same answer, right? And the answer is yes, because if you got 10 equals 10, right, that's A and B, and you subtract 2 on both sides, do we still get the same thing? Yes, 8 is going to be equal to 8. So this is called the subtraction property of equality. If you subtract the same thing from both sides, you're still going to be equal. This one is known as the multiplication property of equality. So if you look at it right here, let's go ahead and get rid of this. If you know that a number is equal to another number, so like 10 equals 10, then you go ahead and you multiply one side by a number and the other side by the same number. All right, so let's start off here. You got 10 equals 10. You multiply this side by 2, and you also multiply the other side by 2. Do you still get the same thing? Yes, 20 equals 20. So this is the multiplication property of equality. Whatever you do on one side, you do to the other side, you maintain equality. And once again, this is review, so I am hoping that you do know these properties. All right, so with this one, it says if you divide by the same number on both sides, do you still maintain equality? All right, so let's write this down. Division property of equality. All right. So we got 10 equals 10, and I divide 10 by 2. If I do that on both sides, do I still have the same thing? Yes, 5 equals 5. Now, this is all granted that as long as you're not dividing by 0. Okay? A plus B equals B plus A. This is the commutative property over addition, right? The commutative property over addition, because we got a plus sign in between those terms. So let's say that you have 5 plus 3, all right? Isn't that the same thing as 3 plus 5? Does it matter who comes first? No, it doesn't. So you can switch them across the plus signs and still maintain equality. This is useful for us when we're trying to put our like terms together. We know that we can move them around and it's not going to make a big difference, okay? It's not going to make a difference. All right, the next one right here is A times B equals B times C, right? So this is the commutative property over, over multiplication. So let's take, for example, we have 5, right, equals 5. If I multiply this 5 by 3, isn't it the same thing as if I multiply it with the 3 on this side? It doesn't matter for multiplication. So this, once again, also helps us in simplifying our fractions, okay, the commutative property over multiplication. This one, next one, it says A plus the quantity of B plus C is going to be the same thing as the quantity of A plus B, and then add C. All right, this is associative because you see those parentheses? and this is for addition. Okay. So let's say that you have 5 and you want to add 3 plus 2. All right. Is it really going to make a difference if you do 5 plus 3 first and then add the 2? No, it's not. You're still going to get 10 equals 10, okay? And the same thing happens for multiplication. Let's see. Let's say if you have 5 times 3 times 2. Was that 5 times 6, which would be 30? It's not going to matter if you do 5 times 3 and then multiply that by 2. All right, so how you associate 3 factors doesn't really matter. Multiplication is multiplication. And once again, it's helpful for solving. This next one is the distributive property. And this says right here, if you have A on the outside and B plus C are wrapped in parentheses, when we distribute, we multiply to each of those terms inside. So have 5 and you have 3 plus 2. That's the same thing as 5 times 3 and then plus 5 times 2. So you can distribute that 5 into each of those terms. This next one is the identity property of addition. And this property states that if you add 0, it's like you haven't changed. If you add 0 to A stays A. It doesn't change. It maintains its identity. So 5 plus 0 is still 5. So no need to write plus 0. It's not going to make a difference. The next one is the multiplication identity property. Because it says if you multiply A by 1, you still have A. So any number multiplied by 1 is still going to be the number, right? The next one is the addition of inverses. We call this multiple things like opposite signs or 0 pairs. So if you have 5 and you add, sorry, I had to sneeze, 5 plus the opposite of 5, which is negative 5, right? They're going to cancel each other. You're going to get 0. And the last one is multiplication property of 0. And this property says that if you multiply anything by 0, you're going to get 0. It's the beauty of 0. All right, so this next part is what happens when we solve one variable equations, okay? Three things are going to happen. Either you're going to end up with one solution, only one real number satisfies the equation. That means that when you plug in that number, it's going to give you a true statement. The left side will equal the right side. Or you can end up with infinite solutions or no solutions, and I'll discuss it in just a bit. All right, so with this one this is the left-hand side, right? This is the right-hand side. On the left-hand side, I'm going to distribute the 2 using the distributive property. So 2x minus 6. Now I'm going to move my x's to the left. So this one right here will be subtract x because it says plus x and we have to do the opposite, okay? And on the other side, remember subtraction property of equality. What you do on the left, you got to do on the right. So 2x minus x will be x, carry the negative 6, carry the equal sign, carry the 5. And now we're going to do the addition property of equality, adding 6 on both sides. And we have x equals 11. So there you go, one solution to rule them all. Infinite solutions is going to happen when your variable, the cancellation of your variable, and you end up with an equality. The left side equals the right-hand side. Whatever the numbers are, they're equal to each other. So let's look at this. Let's distribute the 2. We have 2x plus 20. And here, you see how this 5 and this 15 are both constants? That's going to be 20 plus 2x. I'm going to subtract. I'm going to move my variables to the same side. And voila, they cancel on both sides. And look what we're left with. 20 equals 20. All right, A equals A. So this is infinite solutions. That means it doesn't matter which X you plug in, you're always going to get a true statement. Now, no solution happens when you have the cancellation of the variable. This time you end up with an inequality, something like 5 equals 3, which we know is not true. All right, so let's see. On the left-hand side, I can see that I have two terms with x, so 5x minus 3x is 2x. All right, carry the plus 3. And here I need to distribute 2x plus 6 minus 5. And this plus 6 minus 5 are like terms. This is going to become 2x plus 3 equals 2x plus 1. And now watch. I need to get my variables, my terms with x's on the left-hand side. So I'm going to subtract 2x on both sides. And you see what happens? They cancel. And you're left with 3 equals 1. Is this true? No. All right, so then that means that there is no solution. There is no x value that will ever end up giving you an equality. Identify the properties used to solve the equations. All right, so if we say that negative x plus 22 equals 50 is the original equation, what happened to get to this spot right here? It looks like they subtracted 22 on both sides. So which property was used? The subtraction property of equality. All right, and then from here to here, it looks like they divided both sides by -7, and that property happens to be the division property of equality. All right, the second example, 82 equals 5 plus 7x. That's the original equation. So what happened to go from here to here? It looks like they subtracted 5 on both sides. All right. So this is, then they use the subtraction property of equality. All right, so what happened to go from here to here? It looks like they divided both sides by 7. So this is, we got to x equals 11 by the division property of equality. All right, then to go from 11 equals x to x equals 11, I forgot to mention this property up there, but this is the symmetric property of equality. Thank you, Ms. Pelham. Oh, you're waiting for things to write. I hope you're writing this stuff down as well. All right, let's continue. All right, so here we have to create the equation, the one variable equations, and solve. 100 more than 3 times the quantity. More than means that the 100 is going to come second, right? We have to swap them. More than 3 times the quantity of a number, and 3 is 300. Goodness gracious. So we have 3 times, and then we have a quantity of a number and 3. And we know the answer is 300. So we have 3 times the quantity. A number is the variable, right? X and 3. So inside the parentheses is a quantity of a number and 3. And we want 3 times this quantity. That's why we're multiplying by 3. And 100 more than this. So we need to add 100. And we know the total is 300. Goodness gracious. All right. Subtraction property of equality, both sides. Through. I'm going to use the distributive property here. So we have 3x plus 9, that's 3 times 3, equals 200. Subtract 9 on both sides. We have 3x equals 191. 10, 11 divided by 3. Who came up with this? I don't even know if it's divisible by 3. So we might end up with a decimal. Let's look at this. Oh, yes, that's right. I came up with it. Well, I guess it's 63.7. All right. A hot dog stand made $200 for drinks and sold each hot dog for $2.50. Okay, so they don't tell us more about the drinks except that we made a total of $200 from the drinks. And then each hot dog was sold for $2.50. The total sales were $8.25. How many hot dogs did the owner sell? Okay, we already know how much he made from the drinks. So let's try this. So we know the sales were $8.25. And these sales came from $200 from the drinks and a given number of hot dogs that this person sold for $2.50 each. So that's why we have the 2.50x. And now we just solve. $6.25. All right, and to isolate x, this is multiplication, so we need to get rid of 250. All right, using our calculator, 625 divided by 2.5 gives us 250. So what does that 250 mean? That's the $250 that the owner made from the hot dogs. Write the equation needed to find 3 even consecutive integers that sum to 1362. Even numbers. Well, regardless, whether you're even or odd, right? Your pattern is going to be this. The first number will be x, the next number will be plus 2. Since we got to add another 2, that's a total of plus 4. The next one, we got to add another 2, so that'll be a total of plus 6, and so on and so forth. And we want 3 of these numbers, so we want those 3. And their sum is 1362. All right, so let me get rid of this part right here. So that's 3x plus 6. So 3x plus 6 equals 1362. Subtract 6 on both sides. We have 3x equals 1356. Well, let me just double check. 1362 minus 6. 1356. And now we divide both sides by 3. X equals, and now x is only the first number, okay? So don't get all confused. 452, which means the other numbers are 454 and 456 because they're even, so they increase by 2. All right, the literal equations. And I think a lot of you guys have gotten really good at just moving around terms that don't necessarily combine, okay? So solve for v. Where is v? V is right here. And the fact that they're right next to each other, that means that it's going to be... All right, sorry, I had to close the door. So we know that p and v, they're right next to each other, so that's implied multiplication. So if we want to isolate v, then we need to undo the multiplication, and we undo the multiplication by division. So once you have the same term or the same factor in the numerator and denominator, they cancel. Okay. So we have v equals nRT over p. Right? Number 5, we're trying to solve for v1. So V1 is right here. Now this fraction bar implies division. So V1 is being divided by T1. How do we get rid of division? We do multiplication. So I'm going to work over here. V1 T1 equals V2 T2. Right. So how do I get rid of dividing by T1? I get rid of it by multiplying by T1. Right. So I'm going to multiply the left by T1 and the right side by T1. Now these happen to be the same, right? T1 numerator, T1 denominator, so they cancel. And that's how we're left with just V1. But on this other side, they don't cancel because this one has a 2 and this one has a 1. So they're not the same temperature. Oh. So this will just be V2 T1 over T2. All right, this one, solve for VF, as in final velocity. All right, and our final velocity is right here. Now this isn't multiplication, this is the subtraction of two terms, right? We are subtracting AT from VF. So how do we undo subtraction? We do addition. All right, these cancel. But over here on the left-hand side, VI plus AT, they're not like terms, so we can't combine them. So we have to leave them separate. And that's going to be our final velocity. This one says to solve for B. B is right here. And B is being multiplied to X, and then it's also, we're adding C to it. Now, if you remember, doing operations, when we're solving, we're going backwards on PEMDAS. So subtraction, addition first, then division, multiplication. So in this case, we need to get rid of this minus C. Now we have A minus C. Remember, they're not like terms, so we can't combine them. Equals BX. Now, I know you might want to go for X, but they said solve for B. So we have to get rid of this multiplication, so we need to divide out the X. There you go. B equals A minus C over X. All right, so for this next part is your inequality symbols and ways to describe your symbols. I do believe we gave you a handout that looks like this. And it tells you their name, less than or equal to, greater than or equal to. And it also has keywords, fewer than or under, no more than, at most, maximum, more than or above. Okay, no less than, at least, minimum. So please make sure that you understand them. Also, it tells you that it's going to be an open circle, right, if we don't have an equal sign. And it's going to be a closed circle if we do have an equal sign. All right, the same thing again. It doesn't have an equal sign, so it'll be an open, has an equal sign, so it is closed. Right, back to this. And the only thing you need to remember about inequality is if you multiply or divide by a negative number, you have to flip the inequality. All right, here we go. Subtract 12. Only when we multiply or divide by a negative. Subtracting doesn't count, all right? It still maintains the same direction. X is greater than negative 27. All right, so if we say this right here is negative 27, you see how it doesn't have an equal sign? It's just greater than. That's an open circle. And where are the x's that are greater than negative 27? They're in this direction, okay? All right, solving, we want k, so plus 5, plus 5. So carry the negative 4k, bring down the less than or equal to 3 plus 5 is 8. But you see, we're going to divide by a negative number. So our inequality is going to flip. All right, so we're going to divide by negative 4, divide by negative 4, and I'm going to put a little circle here reminding me to flip. All right, the negative sign cancels the negative sign, the 4 cancels the 4, and I'm left with k. The inequality flips, and 8 divided by negative 4 is negative 2. All right, so let's say that this one is negative 2. It's got an equal sign, so it's going to be a closed circle. And where are my k's that are greater than or equal to negative 2? This way. All right, this one, we're solving for x, and x is right here. So we're going to subtract 17. Bring down this 1/5 x greater than 4 subtract 17. It's going to be negative 13. All right, but here's the thing. Our x is currently being multiplied by negative 1/5. Okay? I mean, really, honestly, the easiest thing to do is to just divide by negative 1/5. But if you divide by a negative number, remember, you need to flip the sign, okay? So that one needs to flip. All right, so negative 1/5 cancels negative 1/5. We're left with x. The inequality flips. Now, what is negative 13 divided by negative 1/5? I'm going to do the math right here on the side. Negative 13 divided by negative 1/5. That means negative 13 times negative 5/1, right? And negative 13 times negative 5 is 65. It's positive because they're both negative. So let's say that this one is 65. There is no equal sign, so it's going to be open. And where are the numbers that are less than 65? They're this way. Yay! Almost done. No. All right. If you can see the plus sign here, that means that this is an open circle. Clear? And the number of interest is down here, which is a 5. And we want all the numbers that are bigger than 5, right? And we said that was an open circle. So we want the x's that are greater than 5. Once again, we can see the plus sign, so that means it's an open circle. And the number of interest is negative 3, and we want all the numbers that are less than negative 3. All right, so x less than negative 3. And yay, finally, we cannot see the plus sign inside, right? So that means it's a closed circle. And the number of interest is negative 2, and we want all the numbers bigger than or equal to this. So x greater than or equal to negative 2. All right, and these are just for educational fun. So here we go. We are solving for x. Sorry, I didn't specify solve for x. So we're going to subtract 6. We have negative ax less than 4. And now we're going to divide by negative a. Right, because we're trying to solve for x. All right, the negative signs cancel, the a's cancel, and we're left with x. We divided by a negative number, so you know what that means. That has to flip. And we have negative 4 over a. And all of this is assuming that a doesn't equal 0, okay? We're going to distribute the negative 4. So we have negative 4x minus 12 minus 2x less than 26. And which ones are like terms? That would be this one and this one. And so what is negative 4 plus a negative 2? So negative 6. We have negative 6x minus 12 less than 26. Okay, so now it's almost easy. Going home, we're adding 12 on both sides, negative 6x, then 38. And we're dividing by a negative number. So you know what that means? That needs to flip. Now, who came up with these numbers that don't divide evenly? 38 divided by 6. It's 19 over 3, which is 6.3. Oh, yeah, it was me. Sorry about that. All right, so I hope you enjoyed this review. Not bad, 30 minutes for almost 3 weeks worth of work. All right, good luck. Make sure that you do your quizzes practice.